Krishni. It's actually nice that we can actually see each other face to face. We did lots of work during COVID, and it's good to be in person. So I just thought I'd start the presentation. One of the previous keynotes said we need to inspire parents. So I'm looking at a STEMI and saying we need an STEMI robotics and coding competition for parents. I think that's a good idea. All right. And also I noted that we shouldn't start with problems. We should celebrate our solutions that have been achieved. So I'm going to tell you, and this is for Burson, we have 25 ECD centers that are doing robotics and coding in El Dorado Park. So hopefully Burson's happy with that. Yay. And I also want to say there are a lot of friends in this audience, and I see Dorothy's here and Walter Sisulu is here. Come and talk to, and Timmy, I've just bumped into him. Come and see what is being done to inspire our youth, because there's a lot of work being done. And I know Anacleta's going to give me another mobile unit soon. Thank you, Anacleta. And last but not least, we touched on the topic of languages. I just want to say, I said Robotics already has an 11-language robotics dictionary available. So just FYI. Okay. Now I can start. Okay, on your mark, say go. All right. Okay, so of all the robotics and robotics and to inspire this country is really my focus. But my colleague Hicho and I, we've kind of honed in on different parts of robotics education, and what we would like to present here is specifically this thing of physics. You know, that subject. And so if you just think of it, these ECD centers that are doing robotics with these grade Rs are doing physics in grade R. Okay, so our 2034 matriculants are going to be awesome in physics, just putting it out there. All right, so this is part of our larger research, and what we just want to kind of introduce where we're going with this research. And am I supposed to click this thing? Oh, my word, technology here. There we go. Okay, so it's about perspectives and opportunities. And although we are inspiring our learners in robotics and coding, the underlying thing is how then do we use robotics and coding to support other science subjects? So whether it is environmental sciences or physics, and so that is the perspective we're going to present today. So physics education, what is that? What do we expect from physics education? And then robotics and robotics education, which is much more practical. You've got to get these robots to actually move. And then what is the status quo? And then obviously there are opportunities within the science Olympiads and competitions for robotics and coding. And then I'm going to present where we're going with this. So I've asked, we haven't got much time, but if you Google what is the definition of physics, you can have a plethora of examples of what is physics, and we've all done physics, hopefully, at school recently. No? All right, but physics in and of itself, the traditional, and I must say that the physics that I did in my matric is not very different to the matric physics that my daughters did. Okay, maybe the book is a bit more glossy, maybe there's a different font, but the content remains the same. And at all times, it's usually abstract. Okay, there's very little practical physics happening in the classroom. But it is a foundational STEM discipline, and it does require learners to develop the scientific thinking. That is where physics is. On the other hand, robotics is where you overlap the engineering, which is practical, the programming, which can become more concrete, and then in between that is, to address the scientific thinking, is your 21st century skills. So your problem solving, your critical thinking, your innovation, and so that is the field in which robotics education is. So how then do we use the benefits of robotics education to address the shortcomings of physics education? Okay. And so we embarked on a systematic literature review, and we considered the extent to which robotics can be used for physics education and also the focus. Obviously, robotics can't be used for all physics, but what is the focus currently? And maybe there's the gap where we can address the gaps. and what is known about the current impacts, and also thinking in terms of your systematic literature review, where does the literature originate? If it's, and we'll put it out there that the African context is not focused, just big surprise. All right, and then does the use of robotics education, physics education to contribute towards this gap that we have, the challenges faced by physics education? All right. So why bother using robotics education to address the shortcomings of physics education? Well, for once, it's the improving the assessment outcomes. Maybe it's a more exciting opportunity. If you tell a learner, let me get to that just now, right. And then for physics training, and then improving learner motivation. I think that's the number one thing. We want the learners to want to learn physics. All right. And if robotics can address that, then I think we've got a win-win situation. All right. So we need to ensure the improved learning outcomes of physics. All right. And we want to align formal and informal. I know robotics education at the moment is kind of teetering on actually as an extramural, and it's going to get into the classroom. We're going to get it there, but at the moment it's informal. But if your informal learning even can be used to aspire learners to do physics, then I think we've got something. And then you use the robots to explore robotics components without giving a child a textbook and saying, now study. Give them the robot and tell them to explore. Okay, so it's a bit more practical approach. And then to consider the perspectives of learner motivation. And I think the educators also need inspiration. All right, so it makes the educator task of kind of exploring and discovering and trying to teach the physics just that much easier. All right. Okay, so I thought of where is the application then on physics in our robotics Olympiads and competitions. For once, there's the momentum. If you let a robot run forward and then backwards immediately, you've got the momentum, because your load is just going to continue. The line follow, where you have reflected light intensity, it's on a scale from 0 to 100. There's no textbook there. You just tell the learners you need to look at the reflected light intensity. Oh, yes, that's the amount of light that's reflected. Okay, so, and then there's different colors. Then the learners already know that, and there's no textbook visible. Okay. The passive and powered geared attachments, without having to explain all the gearing ratios, you've got the learners actually using the robots to understand the concepts. And then, of course, usually the robotics competitions have got a theme, a global theme, and it's whether it's in trash or water or cargo or whatever, and that can also be then related back to research what the learners need to do, and inevitably they will get some physics concepts in that research that they're doing, researching for the good of knowledge. All right. I don't know how many of you have built a robot, but you're welcome. We've got robots outside there. On the exhibition, you can change speed, direction of a robot. There's the momentum, there's the precision, there's the rotation. So all that are concepts that you need to understand to get a valid and reliable robot in any competition. And that's the application then of your physics. All right. Now here's the bargain. So the 21st century skills of robotics education will then enhance the thinking skills in physics. Teamwork. Physics shouldn't be a solo thing. If you're working in a team, you'll understand it much better. There are lots of solutions. The learners need to be encouraged to go and explore the solutions. And one of my favorite is asking the experts. If you don't understand, you're allowed to ask an expert. Okay? And in physics, maybe you're not encouraged to ask, but you do need to ask without having to go through a textbook. All right? And the fun part is, and maybe on all STEMI science Olympiads and competitions, is innovation, where you are encouraged to think, and encouraged to love learning, and encouraged to love finding out things for yourself. And that's the application then of physics. All right. So part of our conclusions were there's an ongoing need to transform physics education. And maybe in that, we're going to get more learners excited to do physics. All right. If it's just from a robot. The one thing is that physics is probably as abstract, and it needs to be made more concrete. And there's an opportunity to identify physics in robotics education and especially, I think, in our African context, there's definitely a need for that. All right. So in closing, we are definitely going to embark on more research. This is definitely ongoing, but to develop specific robotics activities to enhance physics concepts. Hopefully we will have an STEMI paper in 2025 and report back some impact on the physics learning through robotics learning, and that's our goal for this thing. And then this need to include Africa in the relevant literature is what we're addressing through our research. All right. So I'm going to tell you about, if anybody's interested in participating, we've got a lovely science, robotics and coding competition. It's available free mahala. It's on the UNISA MOOC portal. It's got no age restriction, so you can all participate. There we go. All ages, all locations, with any robotics kit, you're more than welcome. And I'm going to conclude with an invitation to participate. And so you're going to understand the physics you never understood at high school. Okay. There's free for all ages. We've got COVID protocols have been observed, not that you need it anymore. There's training, there's recordings, and it's an awesome online community of practice. And I definitely think that through robotics then we can encourage physics education and have learners inspired to join us. And I thank you.
How many?
It is 2 eyes.
I didn't see it.
So on your brain board, here, right? At the bottom, right?